Hello everyone, I hope you're doing well. Today I'm going to walk you through the earthwork quantity takeoff process. I hope this tutorial clarifies many of the questions you might have about earthwork quantity takeoff with Bluebeam. Let's first review the drawings quickly. This project is a 4-unit residential development. On page 13, you will see 3 different scenarios for the site plan. The one we focus on is in the top right corner, labeled as the standard lot. Since we're working on the earthwork division, this will be our primary focus drawing. The second most important drawing we need to use is the wall section, found on page 7. This section clarifies the grades and subgrade levels. The third drawing required for earthwork is the foundation plan, located on page 2. We will use this drawing to identify the amount of extra excavation needed for concrete. With this brief introduction to the drawing set, let's examine the quantity takeoff table templates I have provided for earthwork estimation. The template includes the milestones or activities needed to perform the earthwork, arranged in sequential order. These activities start with clearing and grubbing, followed by the removal of topsoil, cut and fill earthwork, trench excavation, compaction of fill, and so on. If you recall from our past lectures, this takeoff is part of a larger work breakdown structure that follows the CSI master format divisions. For the purpose of this assignment, we are focusing solely on materials, leaving out labor and equipment estimation. To highlight the required materials, I will filter the type column to display only materials. This filtering clarifies that we need to create 6 categories of activities or milestones. Now, I have imported the drawings into Bluebeam software. As you can see, I have overlaid a markup on the boundaries of the plot. Using the area measurement tool, I identified a total area for clearing and grubbing. If you check my legend, you will see that I have assigned milestones from the quantity takeoff table as subjects for each markup. To demonstrate how this works, once you draw a markup, you can select it, go to its properties, and change its subject. For example, I labeled the first markup as clearing and grubbing. If there are multiple markups under the same subject, you can assign labels to differentiate them. You can also customize the boundary color, fill color, and line style according to your preferences. Another important markup is for the removal of topsoil. Since topsoil removal is measured in volume, cubic yards of earth removed, I used a volume measurement tool and assigned a depth to it. In this case, we assume that the topsoil removal depth is 6 inches. This value is set in the volume measurement tool's depth setting. If you check the markup summary list at the bottom of the screen, selecting each markup will take you to the corresponding data in Bluebeam, regardless of its location in the drawing set. Can also view and adjust depth settings under the measurement menu. Unlike the area and volume measurements for clearing and topsoil removal, measuring cut and fill quantities requires referencing the wall section on page 7. I have highlighted key dimensions in the wall section to help quantify the earthwork materials. The green hashed section represents the removed topsoil, which we already measured as 6 inches deep. The next step is to measure the cut quantity for the crawl space. Here you can see a large rectangle extending 3 feet and 2 inches below the topsoil level, reaching the bottom of the granular capillary break. This measurement determines the amount of excavation needed for the crawl space. Since the crawl space covers the entire building footprint, we can use a volume markup with a depth of 3 feet and 2 inches. Additionally, extra excavation is required for concrete. The corresponding rectangle starts at the building boundary and extends to the middle of the triangular section on the right. Its height is 4 inches and its length is 2 feet and 11 inches. To simplify calculations, estimators often use the midpoint of a triangle, converting it into a more manageable rectangular shape instead of a complex triangular calculations. Now, let's examine the excavation needed for the drain trench. The trench has a complex trapezoidal shape, and the site has a gentle slope away from the building. To simplify the quantity calculation, I divided the trapezoid into two vertical rectangles. The first rectangle, labeled cut for drain trench slope, covers the acutely sloped side of the trapezoid. Since only half of this triangular section is removed, I applied half the rectangle's height, 1 foot and 8 inches, when using the volume markup tool. The second rectangle, labeled cut for drain trench, corresponds to the trench itself. The top midpoint is aligned with the slope, and the total height is 3 feet and 5 inches. Returning to the site plan, the third line in the legend represents the cut and fill earthwork for the crawl space, shown with a grid hatch. This is a simple rectangular volume markup covering the entire building footprint. Surrounding this markup is an additional layer representing the cut for the drain trench, shown in purple. To draw this correctly, refer to the wall section to determine the trench thickness, use the length measurement tool to establish boundary placements, draw the larger volume markup for the trench, subtract the crawl space cut volume from the trench volume to retain the correct boundaries. Then repeat a similar method for the drain trench slope. Using these markups, you can also quantify the backfill needed for the drain trench and its slope. The next step is identifying excavation for concrete. Returning to the foundation plan, I marked the locations where extra excavation is required. Different foundation types are represented with distinct colors. Brown represents exterior wall foundations. Red indicates interior pad foundations. Around central walls, the entire area is excavated for practical reasons. Purple shows excavation for balcony posts. Since most earthwork is already captured under crawl space excavation, the additional excavation for concrete is only 4 inches deep. Returning to our quantity takeoff table, we have now captured clearing and grubbing, removal of topsoil, cut and fill earthwork, and trench excavation. The remaining two items are 1, disposal of excavated material, and 2, shoring and bracing. For disposal of excavated material, we calculate the difference between excavated and filled material. The excess, including removed topsoil, represents disposal. Shoring and bracing quantities are measured by calculating the vertical surface area of excavation. In this case, we could use the volume markup for the drain trench slope, but apply the full height instead of half. I hope this review provided clarity on how to measure the quantity of material for earthwork. Please note that we did not account for swelling and shrinkage to simplify our calculations. However, in larger projects, you must consider these factors depending on the soil composition in your project area. Once all markups are created, we can export the markups list as a CSV file to make final edits before submitting the results.